Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about hybrid propellant rockets or hybrid rockets. So let's dive right into it. Well, first, before we understand the solution, we have to understand what the hell was the problem. Because we had solid rockets, we had liquid rocket. What was the damn problem that we started to create these hybrid solutions? So problem is solid, while they are powerful, they are storable, they are like awesome in terms of their raw power and capacity. They are ludicrously inefficient and uncontrollable. Now, inefficient part you can solve by just making it bigger, but what will you do about the controllability aspect? Basically, not only their nozzles are ludicrously complex in order to make it gimbalable, you cannot adjust the throttle output. Basically, if you need for some reason, let's say you are going to max q and you're like, whoa, max q happened a bit too early due to some tornado and all that, or too much adrenaline, you're like, let's throttle down the engine. Solid booster is like, I don't care even if I go through it and I'm going to destroy myself. It does not care. So not having that control, throttle control, is very critical for many applications, specifically if you want to put sensitive humans inside it. So that's the big problem with solid. The liquid, while it is powerful, it is capable, it is idiotically complex. The amount of parts, basically you just open a parts list and the amounts of part that normal, like normal garden variety liquid rocket will consume, it's mind-bogglingly ludicrous. It's like, it's huge. The parts count is huge, not the part itself. Like part maybe, this turbine, the turbine might be this big, but it will need, like, let's say 4 or 5 different types of turbines. In some liquid rockets there is actual water used in pre-burners to keep them cool enough so the turbines do not melt. So you can understand that in terms of parts wise, they are ludicrously complex. The amount of things you have to manufacture for them, it's way too high. Then we come to another aspect of that. Even though they have the power, they're not too powerful compared to a solid booster. That's why even when space shuttle had 3 ludicrously powerful liquid engines which were running on hydrogen and oxygen, they still needed solid boosters to carry them because liquid is inherently not that powerful. So we wanted something that is simple and controllable. Tada, best of both worlds, the hybrid rocket. Now, hybrid rocket, generally, they have solid fuel and liquid oxidizer. Now, there are multiple combinations, depending on requirement, depending on your license, permits, and all that jazz. You will select whatever you can do, because you can, as lowest end, you can directly go with rubber in the fuel side, and in oxidizer, you can do, let's say, nitrous oxide. So you can understand that if you don't have a permit license for liquid oxygens, or technically you don't need a permit for liquid oxygen because you can make it in home, but peroxides you need permission for that. So you can have multiple combination. Each of the blends, so to say, will give you a unique ability one way or the another. Some may be cheaper, another may be denser, another may be more resilient. So depending on you have the combination. Now the reason why we go with this approach is basically it has one control plumbing option. You'll have oxidizer tank. Generally oxidizers are liquid, and that will do the control mechanism. So if you have to tone down, let's say max q is going down, you're like, okay, let's calm down. So you can just tone down the valve, or you can have, if you are running it through a turbo pump, you will like, oh, okay, pump, relax. You can do that. So that is very critical for very serious types of mission where you want the ability to control the throttle and shut it off in case of emergency. That is also something important. So solid boosters have this tendency, like once you lit them, that's it, they will gonna stay lit unless all the fuel is burnt. Here you have that luxury. For some reason, let's say in mid system, you have to cancel that launch or something like that. You're like, okay, let's cut the rocket. You can do that because valve is there. So, and if you need insane amount of simplicity, let's say like, hey, I want to make the cheapest rocket possible, you can just use a liquid nitrogen. Why? Because liquid nitrogen, I'm specifying nitrous oxide, because in certain scenarios, certain combination, it will become self-pressurizing. Basically it will boil off, create gas that will pressurize the system, so you don't even need a pressure system. Sometimes people use helium to pressurize it. Sometimes they use turbo pump if they need a lot of oomph, they want to make sure that they're going as fast as they can, they will use turbo pump. How will they drive the turbo pump? That depends on them. Sometimes another small or solid rocket motors are used. So that's the whole point. Now the profile wise, there is a unique advantage to this. It is denser than liquid. So if you take the cross section of a liquid rocket of the similar power, this will be much smaller in terms of volume. Basically it's denser because, again, solid. So that has a tremendous advantage, specifically if you are fighting against the atmosphere. If you are not doing anything with the atmosphere, everything is space, you don't care. But if you have to go through space, or like you are spending tremendous amount of time in atmosphere while fighting with the atmosphere, making that small cross section is priceless. And then we come to the aspect why we are using solid. It it has the solid advantages where having the high oomph, high density, but it is safer comparatively speaking. Still, we are talking about rocket engines. It is still have the potential to go YOLO boom, but it is safer compared to a normal solid rocket system. So that's what we created, best of both worlds. Now, there may be some other options, but as of my research, only one thing that I could find, Spaceship One was the one that actually went to space using hybrid rocket, and they were utilizing HTPB. It's a quite common fuel blend, with nitrous oxide, basically NOS. So they used this, they went to space, and then they started to create a much bigger variant of Spaceship 1, Spaceship 2, and they're just using the same system. Now, there are certain advantages that this craft need. This is a luxury craft. This is what we call tourist kind of system, basically taking you to ballistic trajectory, you go to space, you float around for a bit, and then you land. So people are inside here. So you have to be make sure, and these people are not signing up to, go boom. They are not astronauts or military pilots. So you have to be extremely safe utilizing both scenario. Both are non-cryogenic. That inherently means if your craft is like, let's say, standing in a launch pad for some reason, let's say in runway some another conflict happened or something happened, like it's delayed there, it will not magically go boom, or like the fuel will need to be redone in order to salvage the launch. That is not needed. So it makes it simpler in terms of launch logistics. That's awesome. It makes it safe because they can shut it off if for some reason they dropped it, fired the rocket, and it's like, no, cancel the launch, something bad is like, whatever the case may be. Let's say a wing flap is like not behaving, or a heat shield is showing damage, they're like, bro, let's cancel the launch. They can do that because they can cut off the oxidizer flow, and it is small. Now that is very critical for something that is airborne, because you're going to spend a considerable amount of time hanging between these planes, and these planes, if it was much huger, even if the weight is the same, if it was huge, physically huge, these jet engines have to spend a lot more fuel trying to push it through the atmosphere. For that reason, hybrid rocket was like a precise fit for them. Then we come to BloodHound SSC. Now, this SSC simply means supersonic car, and there was an earlier version of this which was thrust SSC, and it successfully achieved a Mach speed in Earth, basically on surface. So it's the fastest land vehicle, and the same people who built that thrust SSC, they are building BloodHound SSD, the SSD I'm saying, SSC, and that's why it's called BloodHound SSC. So that moniker is still there, and the idea with this is this time they're gonna try to approach 1,000 kilometers per hour. They want to exceed that point, even by a little bit, but that's the whole point, 1,000. So they are using the same fuel, HTPB. It's surprisingly common. It's also used by ISRO, but this time their basically oxidizer is a bit different. They are not using nitrous oxide, because nitrogen aspect of that nitrous oxide is not adding to oomph. They are using H2O2. Benefit of this, it decomposes through a catalyst bit and gives a lot of steam. That itself adds a lot of thrust, whereas like this can be used as a monopropellant if you just need a little bit of thrust. It will work on its own, but the spare oxygen that it gives off, if you balance it correctly, voila, rocket car. Now, because they want to go fast, and I mean ludicrously fast, that's their whole point, and they are fighting against insane amount of atmosphere because they are at sea level. They don't have the luxury of Virgin Galactic of like 50,000 feet then fight the atmosphere. They're like surface level, sea level. So making everything as compact as possible was necessary. They had to go with solid system. Now, because they want the oomph out of it, they have to pump the fuel much quicker than any pressure fed or self pressurizing system will do. So they put a supercar engine just as a motor pump, basically. So the supercar engine that is running at 18,000 rpm, I have provided the links down below, it pressurizes the main turbine, and that turbine pushes the fuel into the solid grain, and voila. Now, it has not done the actual test yet. The rocket has been tested in test time, not in car while it's running. So I'm not sure when it's gonna be done, because the world ended in 2020. So, but again, this is the another way of doing that. Like Virgin Galactic is taking a much more safe, calm approach. This guy is like, let's go YOLO. This is like brute force, because again, this is so powerful because of the thrust that you are getting burning fuel that quickly. You can literally set it up and it will go in the space, so to say. So this is another approach of hybrid rocket. Now, what about in the future? What we can truly expect in the future? You have to understand this. So, hybrid rocket, by their inherent design, they are not suited for big things. If you really want to make, let's say, Saturn V or Falcon 9, you have to use liquid. You cannot go with this hybrid rocket. And not to mention, if you want to reuse them, again, oxidizer can be refueled, but what you're going to do with also a solid system. So, inherently, it's only suited for small scale. However, that being said, it's not very efficient. Like, it's better than solid, but not that better compared to liquid. Even against basically kerosene, which has the worst specific impulse compared to, let's say, methane or hydrogen, is still really, really bad. So is better than just raw solid boosters, and safer because solid boosters inherently carry their own oxidizer and fuel. So while you are transporting them, any spark, any accident, any thermal runaway, boom. This does not happen with hybrid system. However, liquid also has the same benefit. It's like, just keep them in two separate tanks until at the moment of launch. So this poor specific impulse limits their basically how much payload they can put in orbit, not in like cruising way, as in like actual satellite into actual orbits. So liquid has started to come down in cost because SpaceX kind of created a unique mentality around the world. Basically, the biggest light bulb moment of Elon Musk was realizing that space research actually stopped after 1970 once the Soviet Union fell, simply because again without a competitor NASA was not doing much. So and you see all the engines, I mean like see the engine that is used in Soyuz system, you'll be like, dude, really this engine is like ancient. And again, it does work, but it's ancient. That was the light bulb moment of Elon Musk. It's like, dude, all your designs are stuck in 1970 and we are in 2000s. So what will happen if we build with modern rocket, liquid rocket engine with modern tech, less component? So simplified, like Raptor engine has less components than any other previous systems. Simpler parts, less parts count, more efficient. And seeing SpaceX actually building this successfully, other people are coming in and they're like, hey, he simplified the rocket, how about I simplify it so much that I put a freaking 3D printer and make engines out of it. So this guy made a 3D printer engine. Turbo pumps is the most complicated one. Driving them with a turbocharger is another frustrating thing. But the electric motors, this tiny motor which has 50 horsepower, that's ludicrously powerful, and they're like done. So cost, complexity, parts count, all of them have gone down in liquid such a much that I do not see hybrids picking up too much. Again, there are certain niche where like thrust SSC and Virgin Galactic, there are certain niche that I can see that hybrid rocket will be used, well, technically forever, but I will not see them catching over same way liquid is catching over, because liquid is slowly starting to displace all other solid boosters that we were using for even small satellite launch vehicles. So liquid has a very bright future, but I do not see that kind of brightness in hybrid rocket futures. So this was my presentation on hybrid rockets. I hope you liked it, learned from it. In that case, please click the like button. And if you didn't like it, didn't enjoy it, I'd urge you to press dislike button, press it twice to show me your disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.